All right, everybody, today we're dealing with trigonometric identities right now. Now understand, this right here, this is just a symbol that means the measure of an angle. It's an alpha symbol. It's a Greek letter for alpha, okay? So right now, I'm just going to change it to theta because it's easier to write. I'm going to change this to theta because it's easier to write. I'm just not that talented, okay? Thank you for staying awake, Mr. All right, so what we're going to do is we're going to first write down the sine of theta equals a negative 4 over 5. Now, if you guys look at the sine of theta, that compares two things. I want these in terms of x and y, not opposite and hypotenuse. What does this compare? What does the sine of theta always compare? The y value in comparison to the r value. Now, if you were in my class, you just wrote all of this down, and it means something to you. It might not mean, if you're watching this video, anything to you, but for my class, this means something. All right? Oh, wrong way. This way. Okay. So we know it's the y value over the r value. If you guys would, make sure you put a little arrow and put this is always positive. Your r value in the unit circle, all right? Your r value is always going to be positive. So right now, I don't know my x, I do know my y, and I do know my r value. My r value has to be positive, so I'm going to put a 5. Okay. My y value is going to be a negative 4. And my x value could be positive, it could be negative, but this is a constraint. What does this have to be? The cosine has to be greater than a 0. So if the cosine is greater than 0, I know my x value is going to have to be a positive. Okay? So right now, we're going to do x squared plus y squared equals r squared. Okay? So what are we trying to find right now? We're trying to find x. So what do we have to subtract from both sides? Subtract y squared from both sides. So x squared is going to equal r squared minus y squared if you subtract y squared from both sides. And when you take the square root of both sides, that will give you your value for x. So what is our radius squared? What's 5 times 5? That's going to be 25. What is a negative 4 times a negative 4? Positive 16. Oh my goodness. What did we get? We got a 3, 4, 5. We should have figured this out earlier. That's a 3, 4, 5 triangle. So right here, put a positive 3. Now what I'm going to do right now is I'm going to make a unit circle. I'm going to make a circle that represents our problem. Well, if I square it, if you take the negative 4 and you square it, it becomes a positive.
Oh, okay.
Now, everybody, what I want you to do is right now, I'm going to go make this kind of my x-axis there. That's my y-axis. I'm going to walk over. Oh, that's a little. That was close. That would have been bad. Alright, so everybody, check this out. We know this has to be a what? This has to be a positive 3. So you're going to go over 3, okay? Over 3, and you're going to go down 4, so put a point right about there. So I'm going to color code this real quick. We're going to go over 3. I'm going to go down 4. Stop laughing at me. There we go. And then right here, so I'm going to call this 3. I'm going to call this a 4. And here's a 5. And this is where your theta is. Okay, so this is theta. Now, understand, I understand it's negative 4 because we're going down, right? So what's my ordered pair right now? My ordered pair is a positive 3 and a negative 4. Now this is the part where you need to understand. Your y value technically could be negative in 2 different quadrants. Your y value could be negative in the 3rd quadrant, or your y value could be negative in the 4th quadrant. So why did we choose the 4th quadrant? We chose the 4th quadrant because it said the cosine of theta had to be what? Greater than 0. So if I would have said less than 0, this was a less than symbol. We would not be in the 4th quadrant, we would be in the 3rd quadrant. The most important part in solving this is to make sure that you find the correct values for x, for y, and for r. If you find the correct values, you'll be able to solve everything else. So I'm going to highlight 2 things. One of the things we need to find is the what? The tangent of theta. Now this says tangent of alpha. And the other one that we need to find is the secant of theta. So over here, I'm going to take this right here. I'm going to write in orange, this awesome orange, sickle orange, tangent of theta. And then over here in red, I'm going to write the secant of theta. Now, what does the tangent of theta always compare? What 2 values? Right, in terms of x, y, or r?
Y over x.
Y over x. So I'm going to put y over x. Now, what does the secant of theta always compare?
R over x.
R over x. So when I'm doing this, I always label things first before I put my answers down. Okay? It helps me become more accurate, not less accurate. So now I'm going to take my y value, which is a negative 4. I'm going to place it over my x value, which is a positive 3, and I'm done with that. Okay. Over here, I'm going to take my r value, which is a positive 5, and put it over my x value, which is a positive 3, and that's my other answer. So my final answer for this particular problem, what did we start with? We started with the sine of theta, all right? And we realized that the cosine of theta had to be greater than 0, which placed us in the 4th quadrant, not the 3rd quadrant, but the 4th quadrant. And using these values right here, using the 3, the negative 4, and the 5, we found the tangent of theta and the secant of theta. And these are your exact answers.